Okay, today we are starting a special case when it comes to factoring, okay? So this is still factoring polynomials, but it is specifically differences of squares. Differences meaning subtraction of perfect squares. But it's just called differences of squares. So we're going to start off with showing how to do from multiplying to get to what we're used to and show you that this over here is what's called the differences of squares. All right, so we just multiply through. So I do x times x, and that gives me x squared. X times -4, that gives me -4x. 4 times x gives me 4x. 4 times -4 gives me -16. And what you notice here is you have a positive and a negative for these two middle terms, and they cancel one another out. They're gone, and we're left with x squared minus 16. So we do the next one. 5m times 5m, that gives me 25m squared. 5m times -1, that gives me -5m. 1 times 5m is 5m. 1 times -1 is -1. So the middle, the -5m plus 5m cancels out and equals 0. And we're left with 25m squared minus 1. Next example, 2a times 2a gives me 4a squared. 2a times -3b is going to give me a -6ab. 3b times 2a gives me a positive 6ab. 3b times -3b gives me a -9b squared. And if I simplify these two middle terms, one's positive, one's negative, they cancel out, and I'm left with 4a squared minus 9b squared. What you want to pay attention to here is all of these are perfect squares. X squared, I can take the square root of. 16, I can take the square root of. 25m squared, I can take the square root of. 1, I can take the square root of. All of these are perfect squares. All right. So first thing down here, when you're doing this rule, okay, steps to factor. First, make sure you have an actual difference of squares. That means it must be subtraction sign, and you can square root both terms, both full terms. So use the following rule to factor. If they both can be factored, then that means I can just do a plus b. I take the square root of each one, and I have a plus b times a minus b. And I'll show you what that means. And then you can check it by remultiplying. And when you remultiply, you should get the same answer. All right, so let's look at number 2. Okay. Move this up. I want to see if they're both perfect squares. So if I take the square root, if I do n squared, the square root of that is going to be n. If I take 64, the square root of 64 is going to be 8. They both are perfect squares, so I can automatically plug into my rule. I'm going to have one positive, one negative, and I'm going to have n plus 8, n minus 8, and I am done. That's it. Okay. Let's look at a few more examples in different ways it can be presented. Okay, so here I've got the x term second versus first, which is not in correct standard form, but it can be written that way. So that means I'm going to have, okay, I need to check to see, is 81 a perfect square? Yep, that equals 9. Is x squared a perfect square? Yep, that equals x. So this is a perfect square. A differences of squares, one's positive, one's negative. I'm going to have 9 plus x and 9 minus x. This is my final answer. And this only works because both terms are perfect square. Jumping down to number 5. Okay. What's wrong with this one? If I look at it, this one's not subtraction. This one is addition. I cannot factor this one. This is considered to be prime. Yes, they're perfect squares, but it is not subtraction. All the rest have been subtraction. Okay, let's look at number 6. Okay, we're pulling in some variables in with the terms at this point. So I take, what's the square root of 1? 1. What's the square root of 49y squared? The square root of 49 is 7. The square root of y squared is y. So therefore, both of these are perfect squares, and it is subtraction. So this is a differences of squares, and I have 1 plus and 1 minus. I have 1 plus 7y, 1 minus 7y. So that doesn't look like a 4. And there we go. There's the factored form of 1 minus 49y squared. Okay, moving right along. We're going to flip the page over and work some examples on the back of the notes page. We're going to jump to number 13 real quick. Trying to make sure these videos are not too long, so I might talk a little fast. But remember, you can always come up and ask me a question, and you can also pause and make it go as slow or re-listen to it as much as you need to. Okay, so if I'm looking here, I've got to see, I've got subtraction, so that's the first step, correct? So now I need to see if I can take the square root of x squared, y squared. Well, if I do that, yes, that's going to give me xy because both of them are an even number. And then I have the square root of 1, which is 1. So, yep, I got a differences of squares. So I have plus minus xy plus 1, xy minus 1. And there we go. All right, jumping down, looking at number 15. Well, yeah, 4c squared, that could be a perfect square, but 5, I know darn well that is not a perfect square. So based on this right here, I know right off this one is going to be prime because this is not a perfect square. It's not a differences of squares. Now we'll get to where we can do some other type of factoring with stuff, not specifically this one. This one is prime. We'll learn more tomorrow. Okay, jumping down and looking at number 19. Okay, with this one, I've got something other than squared here. I've got a 6 as an exponent. Okay, so that means if I'm doing that, the square root of 121 r to the 6th, when I take the square root, that means I'm really taking and dividing that 6 by 2. So I'm going to end up with 11 r to the 3rd. And then I have the square root of 1, which is 1. That's the big new thing here is when you're taking the square root of an exponent, it's really like you're dividing by 2 to get what your new exponent is going to be. So therefore, this is a perfect square because we've got subtraction and 2 perfect squares. So I'm going to have 11r to the 3rd plus 1 and 11r to the 3rd minus 1. And that is my factored form. Okay, now we're going to combine what we learned yesterday with what we learned today. And we have to first look for a GCF. So we're going to jump down to 25. Okay, so I'm going to look to see when I look that. I don't know whether 24 goes into 54. I don't think so. So what's my next biggest number? Well, 6 goes into 24 and it goes into 54. So therefore, my GCF is 6. So I'm going to take my 6 out. I'm going to divide each by 6. And I end up with 6, open bracket. I can't think straight. 4a squared minus 9b squared. And when I do that, now I can look to see, is what I'm left with here, is this a differences of squares? So that's where I've got to check my square roots. So I have 4a squared. Yeah, that can become 2a. The square root of 9b squared, that can become 3b. So yeah, those are perfect squares. It's subtraction. So therefore, my final answer is going to be 2a plus 3b, 2a minus 3b. This is your final factored form, and you always have to factor it all the way down. All right, let's do another example with all of these steps together. Okay, 27. All right, I'm looking at 80 and 125 as my numbers. I know 0 and 5, it's got to be divisible by 5. I don't know if anything's bigger than that. So I'm going to just go with the 5. If you want to do the prime factorization to figure something out bigger, you're more than welcome to. But 5 is going to be my GCF for the number. But I've also got to deal with variables here. So I'm looking at, they're both ends. Which one's the lowest exponent? The 2. So therefore, my GCF is 5n squared. So I have to divide each one by 5n squared. So that's going to give me 5n squared on the outside. And then I'm going to have to do what's 80 divided by 5. And that gives me 16n squared, because I have to do 4 minus 2. So that gives me the n squared. And then I have 125 divided by 5. So that's $1.25 divided by 5. So that's going to give me 25. The n squareds cancel each other out. So that's just going to be minus 25. But I'm not done yet, because now I've got to look to see, is this a differences of squares? So I've got to check negative. So the square root of 16n squared, that's going to give me 4n. The square root of 25 is 5. Both of those are perfect squares. So my final answer is 5n squared, open parentheses, 4n minus 5 times 4n plus 5. And it doesn't matter which one's first or second in this, just as long as one's positive and one's negative. And here is my final answer in factored form. Okay, last one, just letters, no numbers. So I've got to figure out what's my GCF. And, well, they both have an M and they both have an N. The lowest coefficients are 1, so my GCF is MN. So that's what I'm going to pull out. I divide each one by MN. That looks like one big loop-de-loop. MN. Okay, so we have, when I'm taking care of the M's, that means I'm subtracting 1. So therefore, this is going to become MN is my GCF. And what am I left with? M squared. The N's cancel. Oh, all of this cancels. So when it's the same thing divided by the same thing, that's going to be minus 1. So I have the square root of M. I need to see if this is a perfect square. I'm jumping ahead of myself here. Need to see if what's inside here is a differences of squares. So take the square root of M squared, which gives me M. The square root of 1 is 1. So I end up with MN, open parentheses, M plus 1 times M minus 1. Again, if you have questions, make sure that you pause it, come and ask, or re-listen to it. You're going to finish the notes and work on the classwork homework. If I adjust, I'll tell you in class. Have a great day.